All right, well, welcome everyone. We're so happy that you could join us today. Thank you for being here. My name is Court Ambrosino. I am an environmental education teacher for Ann Arbor Public Schools. Many of you likely know my colleague, Dave Siegel. Dave, if you'd like to wave and say hello. We're happy to have everybody here. And Dave and I have partnered with another community partner of ours, Joette Rioma, who's also here today. Joette, if you'd wave and be recognized, we're grateful for you. And Joette has helped pull this event together. So wanted to recognize those individuals up front. So 2020 was quite a doozy, and 2021 has also started off with some challenges. So in the EE program, we've been trying to focus on things that are within our control. And we are trying to come out of the pandemic with new opportunities for environmental teaching and learning and environmental advocacy. So we're looking for silver linings. And one of those silver linings has been opportunities to connect with new community partners like Joette. Many of you probably know that we are hoping to start a community garden at the Freeman Center and have compost education going as well. And so we connected Joette with that initiative, and Joette also works with the SEND group. And Joette, would you or one of your colleagues like to just share a couple of sentences about the work that SEND does, please?
Go ahead,
Joette. Go ahead and unmute first, please, Joette.
Well, I can say something about SEND if go ahead, Joette.
David, could you go ahead and say something about SEND?
Yeah, SEND is a nonprofit organization. It's a 501c3 charity established officially in 2020, but it has been operating since 2014 without that designation here in the Ann Arbor region to bring together farmers and different craftspeople and designers around how we're going to build and design sustainable agriculture systems and do other environmental work like environmental restoration of waters here in the Washtenaw County region, from the watershed streams all the way down to the Great Lakes. And you can find SEND online, sendenergy.org. And SEND is an organization that has, along with Project Grow, has invited me to make this presentation today.
Thank you.
Thank you. Thank you, Dr. Benjamin.
And we are happy to have members of that group with us tonight. If you'd like, go ahead down to where it says chat at the bottom of your screen. And if you'd like to introduce yourself in the chat, you can tell us your name. You could do just first name if you'd like, or full name, and tell us your affiliation or your organization that you represent, or perhaps your interest in joining us tonight. So just inviting people to do that. Let us know who's in the room. I know most of the folks, so I can say we have fellow Ann Arbor Public Schools teachers and staff with us tonight. We have students that are a part of the Freeman EE Center Youth Council represented in the call tonight. Really, really happy to see some of our high school leaders with us tonight. We have members of Project Grow and SEND. We have community members. We have many of our EE program volunteers with us tonight. So really excited to see those names and friendly faces, and love to see now people adding their contact or their names and affiliations into the chat as well. We are going to be saving the chat tonight. It's going to be one of the ways that we record questions, comments, and the conversation in tonight's session. So in addition to the meeting recording, as I mentioned, that's another way that we will sort of be documenting tonight's conversation. In just a moment, I'm going to do a brief introduction of Dr. Benjamin. He will be giving a 20 to 25 minute presentation. And again, we do ask that people have their microphones muted during that portion of the talk. We are also going to be turning the chat off during the presentation. I don't know about you, but in some recent Zoom presentations I've attended, the chat sort of tends to distract a little bit during the main presentation. So we're going to turn the chat off in just a moment, and then we'll be opening it back up after Dr. Benjamin wraps up his presentation. And that will be the way that we invite people to submit questions for the Q&A. Okay. We also are going to be sending and sharing at the end of the session a survey that will allow people to submit questions and suggestions as we move forward in our planning. Okay, so that's kind of what our session will look like, and we are planning to wrap up by 5 o'clock. Love to see everybody adding their names in the chat. Really, really happy to have everybody here. Some of you who maybe haven't been in touch recently with us may be curious about what's going on with the EE program or with the Freeman Center. Obviously, we're in a very unique school year. We're not going to get into that tonight because we want to focus on the topic at hand. But if you are interested, please feel free to go to the AAPS Environmental Education Program website. And in particular, the A2C page on our website has our newsletter that has a lot of updates about our program and the Freeman Center and kind of what we're working on currently. And as always, Dave and I are always available. So anyone that wants to reach out and hear more about sort of, updates of what we're working on, you can, of course, feel free to reach out. So sharing a few things before I introduce Dr. Benjamin. So we are considering this environmental technology of an eco-machine as a potential application for the Freeman Center. One of the reasons we're doing that is because many of you are probably aware of the Freeman Environmental Education Center Advisory Committee's work and recommendations that they delivered to the school board in 2018. And one of those recommendations was to develop and install water management systems, gardens, and other grounds projects that tie to environmental education programming. One of the statements that also came out of that advisory committee's work is that the Freeman Center will be a model for sustainable practices in our local community and throughout Michigan. The center will provide inclusive educational opportunities to develop the next generation of informed and skillful student leaders who will address the critical environmental challenges facing our planet. When we learned about this opportunity to connect with Dr. Benjamin and consider a potential eco-machine installation at the Freeman Center, we just thought that it was a great fit for that vision that was laid out by our advisory committee. Now, whether that's a classroom model or potentially a larger scale installation in the future is part of what we're starting to explore tonight. So I'm going to give a little bit of a bio or background on Dr. Benjamin, and then we'll begin the presentation. So Dr. Benjamin is an architect, a scholarly researcher, and a charrette facilitator. His education includes a master's in architecture from Washington University in St. Louis and a PhD in architecture and archaeology from the Norwegian University of Science and Technology. He's a full member of the Norwegian Society of Architects and a charrette facilitator from the National Charrette Institute, lead AP from the USGBC, and a member of the European Association of Archaeologists. Dr. Benjamin is a design architect, consultant on buildings and built cultural heritage conservation, and a built environment researcher focused on the environmental and cultural aspects of built environments and natural habitats and sustainable innovation for the construction industry. He's a registered architect in Norway since 1986 with completed buildings and project designs in Norway, the Bahamas, and the United States. Dr. Benjamin's focus for his PhD was on the relationship between ecology, cultural landscapes, and architecture in prehistoric Scandinavia. He was a Research Council Norway postdoctoral fellow in sustainable innovation research and teaching work at Oslo Metropolitan University in 2010, and worked in the transformation of 5 construction industry partners to integrate the Passive House standard into their value chains. He continues to publish in scholarly journals, conference proceedings, and edited books on the cultural and environmental aspects of architecture and the built environment. He also continues to facilitate different design and organizational transformation stakeholder meetings based on his training as a charrette planner from the National Shred Institute, most recently for the charitable NGO Sustainable Energy Delivery here in Southeast Michigan. Dr. Benjamin is a partner of the ecological water consulting Aqua Naturae, and in the US, the firm John Todd Ecological Design of Massachusetts, where he both advises on business innovation and is active in sustainable landscape design, also incorporating the use of Dr. Todd's invention, the Eco Machine. He continues to also manage his own firm, Phototonica Incorporated, here in the United States, as well as DavidBenjamin Silver Architect Emnal in Norway, and he has taught at architecture schools and research universities since 1990. He's acted as professional advisor for design competitions, convening scholarly and professional conferences and workshops for sustainable buildings delivery, and for cultural heritage management and design policy analyses, including the incorporation of research results into cultural landscape design for Native American organizations in North and South America. It's with great pleasure that we welcome Dr. Benjamin, and I'm going to pass the microphone off to you. Welcome.
Thank you, Court. So I'm very honored to be asked to make this presentation to you about Eco Machines. I've worked with John since 2004 when he and I became business partners in John Todd Ecological Design. And I know what I know and have continued to learn about Eco Machines and their work for ecological restoration, mainly from John Todd, but also from other engineers and designers that have worked with the firm John Todd Ecological Design. These kinds of eco machines, they can either be natural systems or artificial systems built by humans, and they can have many different uses, everything from cleaning wastewater to being infrastructure for learning for students in ages everywhere from grade school to college and university. So he has recently written a book called Healing Earth, where it was published in 2019 by Penguin. He, in that book, explains in a much more detail about eco machines and what they can do to help the earth, basically recover our ecological balance and deal with climate change and clean wastewaters to help, especially places like Michigan and the Great Lakes, which I think most of the people in the room know need that sort of work. So when it comes to teaching, it's apparent to me over the last few years in my own teaching experience that students very often in different age groups, they're mostly living in the sort of environments to the left, which is New York City from above, and they understand the order of that, but they don't often get a chance unless they go to a place like the Freeman Center to get education about the orders that occur in the kind of environments that you see on the right-hand side, which is the Amazon rainforest and the relationship between the water and the forest itself. In classrooms, there's a order for how things are discussed, which is the context, and then there's an order for how the material is put across. There's also the opportunity, like in, for example, the field trips that the Freeman Center takes or on the grounds of the Freeman Center to see other kinds of orders that occur and processes like the decay of the leaves in that tidal pool and the rock. That's also a classroom, especially for environmental education, environmental sciences, all different kinds of STEAM education. Students very quickly, when they begin to gain this environmental education, see that things like parks are very important aspects of the built environment that they themselves live in, such as in cities or suburbs. So as you can see here in Central Park, in the middle of New York City, that's very important for the percolation of water down in to the subsurface layer. If Central Park wasn't there, New York would have serious problems with surface runoff water in the streets. Just like what happens in the picture on the right in the relationship between the forest and the lake that you see there in southern Ontario. So as you back away from New York City, you see that there's other levels of order that take over that appear not quite so structured and artificial, and even humans are called upon to build within the structures of nature, such as the coastline itself of the New York Bight that you see there from a NASA satellite photo. So what are eco-machines? So I put up on the screen a definition that I've worked on together with John for eco-machines that you can read there. I can't read the definition myself because the Zoom screen is covering up the definition, but you guys can read it for yourself. But suffice it to say that eco-machines can be thought of as either natural systems that are used by humans to process wastewaters or to restore ecologies. For example, a prime example would be a wetland that is left untouched, that is healthy, and that percolates runoff water from, for example, a suburb. Without that natural wetland in place, other structures would have to be constructed in order to take care of that runoff water. That's an example of a natural eco-machine. Eco-machines can also be constructed artificial structures that mimic the ecological functions and structures of natural systems. And that's the main subject of what I want to talk to you about today. They can either be constructed as extensive landscapes, or they can be put into greenhouses, or as you'll see, they can be built into small glass structures that look like small aquariums, and they can be put into school classrooms. For example, as you see, an example of one that's about 10 feet long and about 2 feet wide, 2 feet high, that we built. This machine is, we call it a desktop machine. It processes food waste and makes earth and compost out of it in about 24 to 32 hours. And such a machine could be both a teaching machine and a machine that processes food waste at a place like the Freeman Center. So other machines could be, like you see on the right-hand side, a large greenhouse machine. This machine is the one in South Burlington, Vermont, that processes a little over 200,000 gallons a day. It was built for the United States Environmental Protection Agency to study how phytoremediation and ecological machines could function to process sewage, which it was built and designed for, and it was able to process sewage to specification to tertiary standards. These kinds of machines with these tanks can function as a classroom just like the one on the left, we think. And they have been used for that reason. And one of the main reasons why we think that eco-machines are important is that they show processes that occur in nature over time, and that we think helps students to learn about how change occurs not only outside themselves, but their own learning experience changing over time as they become better at learning themselves and also in working together with other students to learn as a group. So actually, John, together with 3 students at the University of Vermont, wrote a book about how students, even at the grade school or high school level, could build their own eco-machines right in a classroom or at home. And these students, a group of about 20 students, in addition to the students that actually wrote the book, which was produced in 2004, and I can provide a copy of the book, I think, to the Freeman Center. I'm sure we can get the rights that perhaps even the Freeman Center can maybe print up a new copy of the book. We can discuss that in the future. This book details in detail exactly how to build an eco-machine that can be used in a classroom environment, at the school, at the Freeman Center, or even at home, and where the students can actually test different pollutants on the machine. As you see from the pages from the book goes into very deep detail about exactly how to build these machines and what the machines can do to teach students about ecological functioning and environmental services. Such a machine can be built for anywhere from $50 to $1,000. And these machines can be fully functional to process water. They don't require a constant supply of water. You just put in tap water and you have a small tap that taps out any extra water that's created by the bacteria in the machine. But the machine functions basically with the amount of tap water that you put in originally. And then you test the machine with things like household bleach or suntan lotion. You see what happens to the bacteria and the fungi and the other life inside of the machine. Some die, some don't. Some take over the roles of the bacteria that have died off. And the student in that way learns about how change processes happen in ecologies. So these machines have been assessed based on what the NASA and the GAO scale calls technology readiness level assessments. These machines, because they've been used and proven over many years, they're at a level of 8 to 9 when it comes to a technology readiness level. So they're completely safe to use, especially when their construction and their use is supervised by trained teachers. Like, for example, we can, Court and David can be trained within a couple of hours of a training session to build these machines on their own. So these machines will help students, we think, who are going to be the leaders of the future in politics and engineering and design and business, to help the life that you see on the right-hand side work and live together with the life and the kinds of structures that you see on the left-hand side, because we know that New York City, that's pictured on the left, is not going away anytime soon, but we have to work to preserve the life that you see pictured in that wildflower garden on the right-hand side. So this shows a diagram of such a large-scale eco-machine in a greenhouse. That's the diagram of the machine that I showed you before in Burlington, Vermont, that treats sewage water to tertiary standards, which is the same standard that sewage is treated to in most cities in the United States to make it safe for disposal. You see here on the left, one of the graduate students at the machine in Vermont, he's got gloves on because he's taking water samples from one of the early stages of the treatment machine, where there's a lot of coliform bacteria that haven't been destroyed yet. In the later tanks, further on down the treatment train, you don't need those plastic surgical gloves to handle the water, as you'll see in the future. The machines can also be outside. For example, this is a pond that takes landfill leachate in near Harwich, Massachusetts, and those green filled clear plastic tanks you see in a row there are a actual eco machine that treats the leachate so that it removes the pollutants out of the leachate, and the effluent water is safe enough to put back into the environment. That pond was eventually, over a span of 4 years, cleaned up so that it could be used for recreational purposes in Massachusetts, according to the Massachusetts EPA. So you can see it here on the right that this high school student, she's actually working on taking samples from this late stage tank in a ecological treatment. She doesn't have gloves on, and it's perfectly safe for her to touch the water. And that can be true for different machines that the Freeman Center could build for itself or for other schools in the school system. Students want to know that they're doing something useful also for the world. This, for example, on the left is a picture of a sewage canal in Fuzhou, China, where we built a machine inside the canal, a series of floating merds that float in the canal and treat the water. And you see after the construction of these planted frameworks that hold the plants and the bacteria and the fungi, that the water is cleaned, and it's actually possible now for the people to use these kinds of machines as a park to walk in. So we think that, for example, these kinds of machines built at a large scale beyond a machine that you might want to build on your biology laboratory bench at a school, some of these machines could be built, for example, to clean the water in the Huron River. And it's possible, for example, to do that as a cooperative project, perhaps with the Washtenaw Community College, the vocational education program there, and MSU and the University of Michigan. So also, there are opportunities for the students in Ann Arbor to interact with other students that have built in the world a network of electronic cooperation between schools to communicate about what's going on environmentally in their environment. This is going on, for example, with school systems in the Bahamas and about reef health. And one of the professors at the University of Miami, Rosenstiel School of Marine Biology, Kathleen Sullivan Seeley, she works on one of these programs on an island called Great Exuma. You see here on the left, that's an image from South America where they have difficulties. So for example, there's an opportunity for the students from Ann Arbor to interact with students on an island called Exuma in the Bahamas, where they transmit continuously this environmental information from a park. The park is actually a part of the Caribbean Sea. It's the first land and sea park in the world, called the Exuma Keys Land and Sea Park. It was established in 1958 by a law of the Bahamian government, and the initiator of this huge park happened to be the guy here in the left-hand picture leading this walk on the beach. His name is Ilya Tolstoy. He's the grandson of Leo Tolstoy, the famous writer. He came up with the idea to start this first in the world land and sea park. An interesting thing about the Land and Sea Park is that it won an award in 2018 for the best land and sea park in the world, the Platinum Award. And I think it would be interesting for the students in Ann Arbor to engage with students in the Bahamas, because according to an astronaut, Scott Kelly, it's the most beautiful place in the world. You can see a photograph that Scott took from the International Space Station on the right. You can see all the incredible diversity of life on these reefs that the students could gain knowledge about and interact with. There's video, and there's also data streaming from these parks that the students could interact with and understand and transmit their own data about the Huron River to students in the Bahamas. Students in the Bahamas have their own program for pollinators also. They These are students on the island of Great Exuma, and they work with a program at another non-governmental organization called the Exuma Foundation. And so there's opportunities also for students in the Bahamas to interact with Project Grow and work on pollinator programs too. I think that also these eco machines, because they deal with issues of what to do about pollution, which is very often an economic and then a political issue, it also leads the teachers and the students to discuss issues such as civic studies and ethics, politics, current events. So there's a broad reach of what these eco machines can help students and teachers to discuss and learn about. One of which would be actually building a machine to deal with the challenges of surface waters and subsurface waters in the Ann Arbor region, like the Huron River. This canal restorer was built in Massachusetts to bring up bottom sediment that was contaminated by bunker oil from ships, and it pulls the bunker oil up from the bottom sediment and cleans it. About 95 to 99% of the hydrocarbons taken out of the water. Such a machine could be put into the Huron River that you see on the left. So you see what kind of treatment efficacy we have in these kinds of machines. This list is a list of a typical treatment level that we were able to attain. This particular example is from the Chattanooga Creek, which we built an eco machine for. Recently, the Chattanooga Creek, after 20 years, finally was certified by the US EPA this year, 2020 actually, as a completed Superfund site. But we were able to treat with our eco machine most of these really nasty chemicals to 95 to 99% removal of these chemicals. These machines can treat everything from, for example, food waste in industrial applications like the one on the left that treats chicken waste, or it could be, these machines can also be simple, small-scale machines that are used to treat sewage, like this one on the right-hand side that treats sewage from a rest stop on a highway in Vermont. You see again here an image of a desktop machine, which would cost maybe $15,000 to $20,000 that would be professionally built. But I want to reiterate that a machine that could be fully functional and of high educational value could be built for $100 to $200 also by the teachers and the students themselves. We think that there's a great deal of application for these kinds of machines to help students learn about many different subjects, especially environmental sciences. And that becomes, for I think these students, gives them an idea of their career ladder after grade school or high school, both as technicians and craftspeople, designers, politicians, environmental scientists, chemists, engineers, all different kinds of people. These machines can give the students not only an idea of their career ladder when they graduate from high school, but also show them that there really is a job out there waiting for them if they pursue this assiduously. And so we can talk about how much a professional machine might cost were it to be helped along or initiated by the Freeman Center. A professional machine that would actually treat sewage or these dangerous chemicals like PFAS and dioxanes, that would be $10 to $30 per treated gallon. That's not a teaching machine though. A teaching machine, like I said, can be built by hand by students and teachers for much less money. So if you want to contact myself or Dr. Todd directly, that's the contact information for both of us. This is being recorded, and I can give that information to Mr. Sigel and Ambrosino, and you can get that information also directly from them. Thank you. So that's, I'm anxious to take questions.
Thank you so much, Dr. Benjamin. I think everyone is applauding from their own homes. And we thank you for this presentation and this opportunity to learn more. I have just opened back up the chat, and just want to go ahead and invite participants to now start sharing any questions that you might have for Dr. Benjamin. We are going to encourage people to do so in the chat, just in terms of turn taking. But if you would prefer to say your question out loud, you could also either turn your camera on and raise your hand, or use the chat to let me know that. And we're going to take about 10 to 15 minutes now for any Q&A. Dr. Benjamin, if you'd like, you can stop your screen share.
Oh, yeah. Okay. All right. Yeah. Just a minute.
And if folks, just reminding you that we are recording the session, but if you do want to turn your video back on, you may. You can, of course, keep it off if you'd prefer. But I like to put my Zoom into gallery view for these types of conversations, now that we're going to open it up and allow for questions.
Gallery view. All right. Wow. So it's, there's a lot of people in the room.
So one question that has come in, Dr. Benjamin, is to share the title of the book that you mentioned again, please.
Oh, yeah. Okay. Sure. Healing Earth. And I've got the book right here in front of me, so I don't have to go back to the slide. So it's the publisher is actually North Atlantic Books. It's published in 2019. North Atlantic is a imprint of Penguin Books. The subtitle is An Ecologist's Journey of Innovation and Environmental Stewardship, Healing Earth. John Todd. I know that it's still available on Amazon and Barnes and Noble, and I mean, even if you Google it on Google, there's many different sellers on Google that sell it also. It's still in print. It's only a year old.
Thank you for that. And I personally wanted to say also the student text, the instruction manual for classroom eco machines, is of great interest to me as well.
Yeah, I will talk to John about getting the rights to that. I'm not sure. It might be that the University of Vermont has a share in those rights. I don't know, because he wrote it with students at the university. But I'm sure there's a way we can figure out how to, get that, and maybe even get it printed up again so that it can be distributed.
Thank you. Question has come in, and it's one I've been thinking about as well. The question is, what things need to be considered for cold climate eco machines?
Well, for cold climate machines, definitely the temperature and humidity affects the activity, especially of the bacteria. Not so much the fungi, because you see fungi growing, in forests, even in boreal forests in, for example, Alaska. But to get the kind of treatment efficacy that you want to treat difficult chemicals or food waste and make compost, you would want to probably use a greenhouse to insulate the activities of the eco machine in the water tanks. However, there are wetlands that treat sewage that have been built in northern climates. For example, it is possible to build a treatment wetland that treats sewage is subsurface. There have been such machines built that treat sewage as far north as Vermont. So it is possible to do, but the highest efficacy, the highest functionality of an eco machine would be in a northern climate in a greenhouse. Yes. So, and it costs a little extra money, but the advantage of treating, for example, dioxanes and PFAS and other difficult to treat chemicals like quaternary ammonium is that when you treat it using plants and snails and bacteria and fungi, mycelium, is that they don't require a lot of energy to do the work that they do to treat chemicals. Whereas when you use conventional engineering to treat those same chemicals, it requires a lot of movement, a lot of other dangerous chemicals, and just a lot more money. So a greenhouse, even though it might cost a little bit of money to build, it's much more effective and cost effective than conventional engineering.
Another question that's come in, Dr. Benjamin, is do you have experience with the use of eco machines and PFAS? And you spoke a little bit about it, but is there any more detail you could share?
We have not actually treated PFAS where we have had the chance to get the effluent typed and modeled by an EPA lab. Even though some of the machines that John has built have treated dioxanes and other chemicals like that. But he has in the machines that he has built, one for Tyson Chicken, which was a food processing machine, the machine that he built for the EPA in Burlington, Vermont, and the one he built in Providence, Rhode Island, and the one in Chattanooga for that stream. There were some pretty nasty, very complex inorganic chemicals that we were able to remove 95 to 99% out of the waste stream. So we're confident that we could treat chemicals like PFAS and dioxanes and other, and even things, for example, that they use in hospitals like quaternary ammonia. One of the things that John mentioned to me recently is that in order to treat those kinds of very difficult to treat chemicals, one of the best and cheapest ways to deal with that is to combine those difficult chemicals with organic food waste. And the reason for that is because organic food waste has such a huge variety and number of very strong bacteria and fungi in it. It attacks the chemicals and breaks them down, mineralizes them. So actually, were a machine to be built, an eco machine here in the Ann Arbor region to treat these kind of difficult chemicals, the most logical thing to do would be to combine it with food waste from food processors where they have to get rid of their food waste anyway. And instead of throwing it away, they can use it to process dangerous chemicals. So it's a sort of a win-win.
Another question that's come in is related to some of the byproducts, and I'm sure it depends on what kind of system and what it's treating. But are there, in general, can you talk a little bit about what kind of byproducts come out of the machines, and specifically, do any of the organisms that are used in the machines need to be replaced or disposed of themselves after treating?
So the main challenge of species that grow and sometimes need replacement are the macroflora, like the grasses and the plants. And that's very often seen, for example, in outdoor machines where you see like a planted meadow or a wetland that treats waste. However, with the tank-based machines in greenhouses, usually those plants last for many, many years, and they really don't need replacement. They pick up the difficult to treat chemicals, and they mineralize most of them. So that's why the chemicals don't have to be disposed of, because the chemicals are literally broken down into their component parts for most of these machines. Now, all right, we have not yet built a machine that where the EPA has actually tested the effluent for treating things like PFAS, but we're confident that such a machine could be built that would have treatment efficacy and would be cost effective. 20 years ago, he built a machine or several of them that treated those very complex chemicals in the Chattanooga Creek. So since from 20 years until today, ecological engineering has progressed by leaps and bounds. So there's quite a bit of data to show that I think we can be fairly confident that we could treat those difficult chemicals and dispose of the effluent in a safe way. For example, one of the machines he built was very quickly, for a brewery. And breweries throw away a lot of solid material as waste product from, it's actually the waste product from the hops that are unused by the fermentation process in making beer. What he took those, that fibrous material that comes from brewery waste production, and he took that fibrous material, put it in boxes in basements underneath the brewery, and he grew, I think they still grow mushrooms on that brewery waste, and the mushrooms are of a quality that can be sold in food stores. So they're food grade quality mushrooms grown on brewery waste. So that's another win-win sort of situation where you create a circular economy. That sort of thing can be done without too much, high-priced engineering skill in a place like Ann Arbor.
I've had a number of comments come in, Dr. Benjamin, about the design potential. We know that, in the NGSS, the Next Generation Science Standards, design and engineering skills are important aspects, and that portion seems to have struck a chord with a number of participants about the opportunity for students to be involved in the design and perhaps construction of the machines. So particularly, I've seen a few comments on interest in that student instruction manual that you shared, and sort of a follow-up question for you, I think, would be, to what extent, obviously for a larger scale, more permanent functioning system at the Freeman Center, after it's built, right? And it's more about learning about how it's functioning and maintenance and those sorts of things. But do you have any thoughts on sort of how this could be utilized in a lab space where there could be component parts and students could be creating their own simple systems using some of the key materials that are used in these types of machines that could then be taken apart, and next batch of kids comes in the next day and tries their hand at design and construction?
Well, I think that, for example, if you've got a cohort of maybe 18 or 24 students, 30 students in a class, and the class meets 2 or 3 times a week, or maybe once a week, you could divide up the students into groups of 4 or 5, and they build their own machine. And so out of that cohort, you might get 4 or 5 different machines. that they would build either on the lab bench at the Freeman Center or at a school, or, I mean, if there are students in Vermont that have built these machines even at home, I don't know if you'd want to do that here in the Ann Arbor public school systems, but you could certainly do it, you know, at the school or the Freeman Center. And what I would suggest is that different groups of students build different machines and they test them with different pollutants, and that different students build and design their own machine based on the guidelines in the book that John wrote, and they test out their theories. And by trial and error, they learn what works, what doesn't work, what's easier to build, what's not so easy to build. It's a learning experience. And that machine that let's say a cohort in 1 year builds, it could be used as a model for the next year, or that machine could be taken by one of the students. And so you get the next year's students to build a new machine for themselves. I believe that one of the biggest values of these machines is not just using the machine to learn about ecological functioning, but also the building of the machine itself is instructional. And it gives the students a sense of success and worth when they together are able to construct and finish something on their own. I think it would be a very fulfilling experience. And it's possible to do it. John claims you can do it for 50 to 100 bucks. He said most of the parts and pieces you can buy at aquarium stores. And just add tap water and some food and you're off to the races.
Well, I'm very excited about the range of possibilities and scales here, and I can, in my own mind, envision a range of applications. I'm seeing a number of comments and questions that have come in that show participants are enthusiastic about these ideas as well. We are coming up on 5 o'clock here, so we are going to be wrapping up this initial session soon. I want to just reiterate that this was meant to be an introduction and an exploratory conversation. And we're so grateful to Dr. Benjamin for sharing his expertise and planting these seeds with us as we begin this journey. I right now am going to place in the chat a Google form that participants can use to give some feedback to us. If you go ahead and click that form link, you'll see there's a place to submit further questions that you might have, suggestions or ideas that we could consider at the Freeman Center or beyond within Ann Arbor Public Schools, and also whether you'd like to be involved in any further conversations and planning moving into the future. We will be sharing, probably tomorrow, a follow-up email as well that will have the form link, the recording, and we're also going to be sharing, saving the chat from tonight. I do see there are a number of comments and questions that have come in that we did not get to during this first session, so we will be following up. Okay. So again, I want to give a big round of applause and thank you to Dr. Benjamin for his presentation tonight. We'd like to thank all of you as well for attending and taking part in tonight's session. Really pleased to see so many different stakeholders here tonight, all different ages and areas of expertise and interest. So excited to move the conversation forward. Hope everyone has a great night. Be well, and we'll hope to see you soon.
Can I make can I say something, Court, before they leave?
Please.
I'd like to present a challenge to the Ann Arbor Public School group of people. Is the book that John wrote with his students, I'd like to put before you the challenge for you to decide if it's out of date. Maybe you need to write a new instruction manual yourselves.
Love that. Nate Hatt is on the call. Nate, I think he's talking to us. We'll maybe take up that challenge.
Okay. John, I think would help you write that if you can find a little bit of money. He would help you definitely write that new book. And that's something you could do open access, perhaps even for the school systems in the United States.
Love that. Well, thank you again. I'm going to go ahead and stop the recording. Folks, please do share your thoughts via the form, and we'll be in touch very soon. Thanks, everybody.
Great. Bye.